Alright, so if we look at net ionic equations, these are where we write the equations, but we only show the things that are changing. We don't need to show every single thing, because if something's not changing, chemists generally don't find that interesting. So if we mix some things together and nothing reacts, and we talked about this with the metathesis the other day, if we have two pairs of ions and they don't form a solid, or they don't form water, or they don't form a gas, they're not really changing. They're just all kind of sitting in the same solution, but not mixing at all, not reacting with each other. So those aren't interesting to us. So what we do is we actually eliminate, for most part, any of those ions or those species, as chemists would call them, that aren't participating. And we call those spectator ions. So our three basic steps. First, write the molecular equation. The slide says to balance it. I usually don't balance it until the end, because you have to end up rebalancing it anyway. So I don't bother balancing it until the very end. Second, you take everything that's aqueous, split it apart to show the ions that form in solution. And lastly, anything that doesn't change from one side to the other are the spectator ions. You can cancel them out. Now be careful. Every time you get a solid, using your solubility rules, make sure you put the little parentheses with the S. Or if you get a gas, put the parentheses with the G. Or if you make liquid water, molecular water, put the parentheses and put an L. Because that thing, the solid, the gas, or liquid water, doesn't actually change. Or did change. So you've got to keep that one. It doesn't get eliminated. The other ions that are positive on both sides or negative on both sides do get eliminated. So if you have hydrogen and hydroxide on the left and liquid molecular water on the right, you would keep all three of those things. Anything that's an ion on the left and still an ion on the right, you can eliminate. Those are spectator ions. If it helps you to think of spectator ions as like spectators at a basketball game. They're there, they're watching, but they're not actually participating in the basketball game. Same thing with spectator ions. They're there in the solution, in the beaker, but they're not actually participating in the reaction. So they're spectators. So here we have the sample problem. We're looking at mixing an aqueous solution of iron 3 sulfate and lithium hydroxide. We know it's iron 3 sulfate because the sulfate has the 3 subscript. So with the swap and drop, iron had 3, sulfate, the 2 from sulfate, went for 2 irons. So we also know that these are both soluble because it tells us they're solutions of iron 3 sulfate and lithium hydroxide. So in a problem like this, we can already assume that both of those are soluble. If we go back and check the actual solubility rules, we'll see that sulfates are usually soluble, except with just a few things. Iron's not one of them, and lithium is always soluble with everything. So the lithium hydroxide is definitely soluble. So our first step is to write the first equation. And we write that. So we write the 2 as the 2 reactants with the arrow to indicate that a reaction is going to happen. The next step is to split these into the ions. And at this point, for something like this, we don't care about how many ions each splits into. So even though there are 2 iron, 3 ions, and 3 sulfate ions, for now we're just going to ignore the coefficients. So go ahead, pause the video for a second, and split each of these ionic compounds into their ions. So you have 4 ions, 2 cations and 2 anions. Once you've got that written, hit play again, go check the next slide. Alright, so this is what we should have: an iron 3 ion, a sulfate ion, a lithium ion, and a hydroxide ion. The next step is to kind of mix and match and see if any of these are going to give us a solid or a gas. So take the iron 3 with sulfate with hydroxide. Will either of those give us a solid or a gas? Take lithium with the sulfate with the hydroxide. Will any of those give us a solid or a gas? Look at your solubility rules and see if you can figure that out. Pause the video. See if you can figure out which the solid, the precipitate, or the gas is going to be. Alright, so we've got iron 3 hydroxide. Hydroxides are in general not very soluble. So iron 3 hydroxide, not soluble, that's a solid. Notice I put a little S after it to indicate it's a solid. Lithium, again, lithium is always soluble no matter what it's with. So lithium and sulfate are left over. They're not going to make a solid. They're not going to precipitate. Now, I didn't put the AQs in for any of the ions because if you have an ion, you can assume that it's going to be soluble. It won't become an ion unless it's dissolved. So now the next step is to go through and cross off the spectator ions. Remember, the spectator ions are the ones that we can eliminate from both sides because nothing changed on both sides. Go ahead and pause the video here and eliminate whatever's the exact same on both sides. Alright, we have lithium, the lithium ion, same on both sides, we can cross that one out. And we have the sulfate ion on both sides, so we can cross that one out. So all we're left with now is iron 3 and hydroxide on the left, and then the solid iron 3 hydroxide on the right. Lithium's gone because it didn't change. Sulfate is gone because it didn't change. Those two are the spectator ions. So where it says list any spectator ions, those are the two. So we just eliminate the spectator ions, and here we just need to balance the equation now. So pause the video, take a second, balance the equation, see what you come up with. Great, exactly right. 1 iron 3 plus 3 hydroxides will make iron 3 hydroxide solid. The spectator ions were the lithium ion and the sulfate ion. Excellent job.